Hi, everyone. My name is Eunsol Choi, and I'm a professor at NYU in computer science and data science department. This is a very different audience for me, but I'm very excited to talk a little bit about what we do in academia and what kind of problem, what we think about, and how it relates to open source. So if I look up the definition of open source, it says open source products, initiatives embrace and celebrate principles of open exchange, collaborative participation, rapid prototyping, transparency, meritocracy, and community-oriented development. This really sounds a lot like academic research. A lot of this is baked into the system of academia. We have conferences. Where am I supposed to point this? Yes. We have conferences where we're exchanging ideas and build communities. And we are also very flexible in collaborations because, people are not bound by, company laws and stuff, so we can collaborate with anyone. And also, research projects are a lot of times prototypes that's pretty quick, and we just build our stuff, and we don't have to think about the users. We just build and test out the ideas. So it sounds really cool, but I think there are some difficulties of doing open source research in academia as well. First is even though it says it's open source, some of the journals are actually closed and it's not always easy to publish. And some of the data that we are handling are, for example, I have collaboration with medical school, and those data is not really can be open source because they contain sensitive information. And lastly, research prototypes, they are rapid, but also they are not very well maintained. The students graduate and the code is not working anymore. So there are some challenges of keeping really open source thing in academia. So in the remaining time, I'm going to talk a little bit about how open source is shaping academic research and what kind of research topics that we are doing in academic natural language processing communities these days. Okay. So I'm going to talk a little bit about different levels of access that we have with LLM. So the premier models like GPT-4, Gemini, or Cloud, these are API access only model where you can just send the input and get the output. In the next layer of access, we have model weight access models such as Llama or DeepSeek, where we can actually download the weights and then do something with it. And then you might think these are sufficient, but actually we think there is another layer of access, open source access models, where we can actually know what kind of training data was used to build these models, what kind of recipe was used to train these models and everything. So full-blown resources to enable reproducibility. So doing research with the API only access model is Percy from Stanford was making an analogy. This is basically like a cognitive scientist doing studies with humans. So you cannot really control them very well, but you can only give the input and observe the output and kind of try to see what's going on. But the nice things about these models are they're very powerful, and we can build agents that can solve complex tasks and build complex systems with these kind of models. So, a bit weird. Anyway, the frustrations of building with these models is the reproducibility, which is key in academic research, is really challenging. These models change the versions all the times. We cannot really know when it's going to disappear. So research is no longer reproducible. And also because you can only interact with input-output pairs, we have a limited pathway for improving the system. You cannot really change the weights or build something on top of it that easily. But we can still use these black box systems that's very competent and doing a very general sort of task to change it. I don't really know why the slides are a little bit weird. And then we also try to build a controller that can kind of surround these black box components. And we actually train these controller. We take actions and observe what happens. And then based on those rewards, we can update the models. So here are some examples of kind of research stuff. One was actually from OpenAI dealing with these kind of black box models. And even though they are black box, we academics also try really hard to understand what's beneath the black box models. So we can kind of do controlled studies of input and output to see what kind of things, behaviors are happening underneath. So there was this famous study where you are using the retrieval augmented generation. And if the information that you're looking for is presented in the middle, then the model does not use that information very well. And we also saw that the order of the information that's presented in the input decides the order of information that's generated out as an output. So these are kind of like not desirable behaviors of these black box models that we can study. And then another example is the academics also found that the sentence that's written in rare languages takes more token cost in the API, meaning that it's broken into more tokens. So, and based on these observations, we can also change the model with the open weight models to build the systems that can add vocabularies for these rare languages to improve these disparities. Once we get to model weight access models, such as Llama or DeepSeek, then we can do a lot more with these models and do a lot more research with it. So we can kind of make analysis. These are like our neuroscientists that can probe the internal activations and then also can build something with these models on top of it. I would say like 80% of academic research or even more is built on these kind of open weight model. These are the stuff that we are using a lot. And it's really nice that it's reproducible. People have this checkpoint that they can reuse. We can fine tune them. We can study merging and compression and all these kind of things. But it's still limited on what kind of architecture that we can use because we are limited by the architecture that's released by the model providers. And we don't know what was kind of design decision that led to such models. So we don't really have the knowledge of what's beneath it. The next layer of access is open source access models such as OMO and DataComp. I'm actually curious, how many of you have heard of OMO here? Okay, how many of you heard of Llama? GPT? I guess everyone here, yeah, okay. Yeah, so these are really fully open source versions of language models. And with this, we can really study everything from data to architecture to training algorithms. And they allow you to use it, study it, modify it, share it afterwards, and come with all sorts of details like what kind of pre-processing was done, what kind of like training procedure it has went on, how did they choose the checkpoint, how they do the inference. All of these are released to academics and people to study. And I think there are academics who wants to develop this open source LLM. And I think it's kind of, there are arguments for both. As a professor somewhere, why do you want to build this? So one big negative thing is like, typically in academia, we want to build a pond that's out there, right? But here, that these products are already out there, but that just because they are not released, we are putting a lot of efforts to reinvent this wheel that's already existing. But while rebuilding this, I think the people who are actually doing this open source LLM gain a deeper understanding of the models, which is helpful. And once it's successful, it's going to get released and be used by so many people to support a wide range of research questions. So that's really exciting. It's going to have a large impact if it's successful, but it also requires a really large amount of investment, both in terms of compute and also human resources. And I'm going to talk a little bit about the investment part a bit later. And I want to kind of walk through one of the examples of, I went back. Anyway, my colleague Shinji, who's at CMU, and he's been like trying to reproduce one of the open source model. And then from OpenAI and from Meta. And basically, even with the help of the engineers from Meta's and Google's and so forth, it took like 2 years for them to reproduce such things. And while they are going through the path for reproducing this really large scale closed model, like these are some of the things that they have to do to make training cost way cheaper. And these are cool tricks, but if you look at that, these are not kind of contribution that can become a student's PhD thesis or even master's thesis. So there's a lot of like engineering things and human resources that's necessary that goes in there. And impact is great once you produce the output, but they are not really easily publishable contributions. So the alignment with the academic incentive structure is a little bit off, I would say, in that aspect. Despite that, we academics really care about science and want to reproduce and understand the technology behind it. So there are a lot of large-scale open source LLM efforts out there. But they are really joined force of like multiple institutions as well as some non-profit or for-profit organizations. For example, the open source language model that I talked about is 4 universities and AI2, which is a research institute in Seattle. And Datacomp is another well-known effort. It has 7 universities and 6 other organizations, including like Apple and Google Research. And the other one also has like a lot of people. And I just wanted to highlight some of the people in academia, including my former advisor, Luke, and Hannah, who was also at UW, and Ludwig. He's also working on some of the vision models, and Sasha, Cornell Tech, and so forth. So these are kind of people who really puts efforts into open source efforts in academia. And one thing that's still a little bit frustrating for doing this is like the green bar is the OMO, which is the best open, fully open source model. And you can see the performance, those are kind of exact match, so higher the better. The gap between open weight model and fully open source model is still pretty big. And the gap between the closed model and then the open weight model is catching up, but there is still always a kind of lag between fully closed model versus open weight model. So that's one thing that we are still, the community as a whole is still working on. But the nice thing about this really open access model is it helps us to study the research questions that we could not study with open weight models. So for example, this was a study from KAIST that were looking into how language models training is impacting the parametric knowledge, and they are forgetting and acquisitions. And because the open weight models are releasing multiple checkpoints throughout its training, you can study these kind of research questions, which you cannot do with like one end product llama model checkpoint. Also, we can study kind of LLM's generalization patterns. So we can kind of look what kind of questions were in the training data, and then what kind of questions are in the test data, and then see how much model can answer if it was not present in the training data. These kind of studies you can only do with open access model where you have access to its training data, but you cannot do with black box weights that's just given to you, but you don't know how it's made. There are some limitations and opportunities, even with these models. So I think one thing is like, even though these are almost reports everything, it doesn't mean that my lab can reproduce it. It still requires a significant amount of compute and infrastructure to reproduce. And they are very complex systems. So even though you know what's there, it's really hard to understand what was the key aspects that made this happen. Another cool research directions that people are working on is looking at scaling. Can we try and understand the systems in the smaller model and then reproduce what happened, what learned there to when we are actually generating a really large scale models? Yeah, so I think that's kind of what I wanted to cover about how open source is shaping what we can do in academic research. In the remaining 5 minutes, I'm going to talk a little bit about some research topics that's going on. I think AI, I think there are so many people working on NLP these days, but I think when we started studying NLP, we are kind of interested in language as a phenomena is themselves. We like that they are compositional, so meanings can build upon each other. They are open-ended and they keep evolving. New things keeps coming up. And also language can express abstract, hypothetical, and moral arguments. These things are all possible with language. Language also is the way that we pass on knowledge from one generation to the other. Allows people to have vicarious experiences, and it's really serving as a ground for artificial intelligence. And when we are studying a language, I think it's really frustrating. Anyway, you guys are all smart and can understand what was there originally. It meant motivations in academia. I think academics are driven by the research impact, either theoretical or practical, long-term or short-term, but also driven by curiosity, and we would like to do some fun project that we are intrinsically curious about. And I think there are some social framework as well, incentives to develop a research identity as a researcher, to be known as a one person. Oh, she's working on like multi-LLM, like she's working on QA, she's working on decoding. Like these kind of identities are really important to grow as an academic, and to build a research community surrounding the identity that you are building. So what I have been working in my lab, so we've been working a lot on like building a bridge between humans and knowledge. So large scale knowledge that's in the text. And there are many applications like journalists trying to process a large volume of documents and so forth. And we build you ask a question in natural language and provide an answer in natural language. So building systems that can interact with users to find information and reason about it. And for that, I think hallucination is a very big issue. We want the information from these systems to be accurate. But another aspect that we are focusing a lot these days is about the mode of interactions. So in this New York Times article, they were saying that one thing that they really liked was the model being able to ask clarifying questions. And I think if you think about the interaction with the LLM, even the premier LLM, the interaction pattern is a little bit different than when you're asking the same question to human experts who has a lot of knowledge about that topic. So for example, if I ask about hotel recommendation in Austin, GPT generates a really lengthy things, and I checked it, and they are mostly correct. They are factually accurate statements. But this is a little bit different modes of interaction than when you are asking it to human experts. Travel agent, they will be coming up with what's your price range, what's your location preferences, and then you are gonna proceed with the interactions. So we've been looking into how can you teach LLMs to interact more like humans, taking initiatives and be able to have this more natural interactions than the interaction that we are currently having with LLMs. Another aspect of problem that we are looking a lot is when the user input is ambiguous. So football can mean either soccer or American football. And based on different interpretation, LLM just picks one randomly typically and provide an answer. But we would like the model to be able to generate more comprehensive answer or come back with a clarifying question whether you meant a football or soccer. So these are kind of things that we are studying. I don't think I have time to go into details of how we are building these systems, but we build kind of annotation, preference annotation frameworks, and then learning to be able to encourage this kind of clarifying question asking activities. And we are also interested in studying the interaction with LLM assistants. In the code assistant models, the model should be also be able to ask for clarification about what kind of algorithm do you really want to get out of the LLM, and then the user provide more specification, and then the model generates. So kind of allow more efficient interactions. Okay, I think that's what I wanted to cover. I would like to thank my students and funding agencies and so forth, and I will be around.